In a world of mediocre 5-axis work holding solutions, one company, Dragonfly Engineering, stands above the rest and sets a new benchmark for standard of quality of next generation 5-axis work holding. So with no further delay, today we introduce the Dragonfly Engineering 6-inch work holding vise 6 million.
Are you crazy? Or just plain stupid?
Hey everyone, welcome back to Dragonfly Engineering. So yeah, we've developed the premier 5-axis work holding solution here using the Olympia bench vise, which you may have seen in previous episodes where I was tinkering effectively just on the bench. So I don't have a 5-axis fancy tool holding system that will allow the spindle and the trunnion to rotate the part around to pick up 5 sides to do ideally, or in this case, a single op milling operation. And when I say a single op, when you load the stock into this bench vise, the program basically rotates the material around such that the entire part is machined in a single operation. So no zero op where you machine dovetails in or anything. Effectively just the stock sticking up above this bench vise allows for all of the sides to be machined, and one side of the finished part doesn't have any holes or other features. So we can part the part off in the flipped over side position, and we effectively tab off, or it's also called tabbing off, where we machine the final side down to the point where there's just a tab of metal left, and then you can break that off. And then you do have to cut off the little tab and deburr that, but effectively just using a bench grinder or something. So eventually I do hope to either buy or more ideally design a 5-axis work holding solution similar to what you see out there in the market. But in my case, I need to have, or I would like to have, a automatic clamp so that this KUKA robot, which is still sitting here waiting to be deployed, can load parts into a 5-axis clamp where the robot actually gives the command when it's holding the stock into the top of the clamp to close the clamp. So it'll probably have some sort of air cylinder or some other type of toggle clamp. Perhaps hydraulic, but probably air actuated with like a vice grip style toggle clamp, similar to the dual shot molding machine that I've got next door. So I am going to show you the process of machining a bracket. Let me go get one of those so you can see. Yeah, so I've got these two kind of complicated brackets with holes and features and big notches cut out on all sides effectively. And then here's the other one. So I'm going to show the operation of machining both of these aluminum brackets, which are effectively just they're structural members, and there's threaded holes on the ends and countersunk through holes on the side, tabs and things to hold other bits and bobs, and notches to clear out. So we're going to machine both of these with a single setup. So stock loads into the vise like this right here, and this part will come out at the end of our operation. So let's do that now, and I will show you the Olympic 6-inch bench vise in action, or I should say the Dragonfly bench vise 6 million, soon to be available on the market if you'd like to buy your own. All right, so let's get going machining. All right, so we're gonna set our stock, or reset our stock. You can see with this 6-inch vise, here, let me rotate the axis. Whoops, wrong direction, don't want to do that. There we go. I can basically put deep stock in this vise all the way down to where the draw bar is, and I think I can get like 3 or 4 parts in the Z axis. All I have to do is reset the height, and I started and stopped the program. So this is the first planing operation, which would be, up here on the part, which has been tabbed off already. So I believe, according to the toolpath, that we have 2 1/8 inches, but I can measure our first cut right now anyway. And yeah, it is 2 1/8 and 1/8 inch. So I will bring the Z up and send it to the back. I'm just hand jogging the mill right now. And we can do a 0 return all to basically bring everything back to 0. Oh, I gotta close the door for that. One disadvantage of this mill is that there's droplets on the window, so it's hard to see what's happening, but I may get one of those little centrifugal window deals and stick it on here for video purposes. All right, I'll hit 0 return and all. So now everything will go back to its home. And it actually, I believe it does a rehoming calibration as well. Okay, so it's done with that. Oh, I gotta wait for the door to unlock. We can reopen. So with this bench vise, this handle can flop around, and when the vise rotates, it could be that this handle is actually sticking up and may crash into the spindle and some of the orientations of our work holding. So I've got these cant twists, and I'm gonna stick another cant twist on this side to keep this handle from moving around. You know, because the spindle is gonna be coming in from this direction, and it's gonna be coming in from this direction and that direction. And effectively, we need a pyramid type base that then has a 5-axis clamp on the top, and that's how most of the, like the HAAS 5-axis clamp or other work holding solutions, they all have this pyramid, because you have to clear basically this triangle of clearance on your spindle as you orient your table in all the 5 orientations, you know, front, back, side, or left and right and top. Right now we're in the top orientation. So you'll see that when we actually run this part, how why we need kind of the triangular shape with our actual stock sticking like way out away from the work holding. Okay, so let's reset our stock here. There we go. Yeah, and it's basically just clamping the part in, no parallels or anything, but I am going to use this 1, 2, 3 block to set the new tool height, or the stock height in our bench vise. So I've already basically found the center of this bench vise and actually downloaded a model of a similar bench vise online and put it in the Mastercam toolpath. We're not really going to get into the toolpath part because I'm not exactly an expert in that yet. So this is a little tricky to do, but it saves a probing step, basically. Because as long as the stock is, as long as our part is inside of the stock that we set here, then we should be fine. So I'm just getting it roughly centered on the vise and at 2 1/8 inches above the top of the vise. And then we'll tighten it down. It can be a little taller than 2 1/8 as well. You're just wasting stock, but you don't want it to be too crooked because we're cutting basically perpendicular to the spindle for our top plane. Now you gotta tighten this thing down really good though. And I do have almost full coverage on the removable jaws of this bench vise, because we don't want this part to start rotating or rolling on us, because we don't have any other reference or parallels. So I'm going to give it a good tightening, and I think that'll be out of the way. Actually, we can just have a single clamp, I believe. So that's. But, you know, whenever you have a new setup, it's good to basically run a option stop where you stop between each operation or tool change, just to make sure you're not going to crash anything. The biggest concern of crashing with a 5-axis is that the tool is still here and the trunnion starts to roll and the tool actually will hit the corner and break off or jam into your spindle and then damage your spindle potentially. All right, so that's not going anywhere. So I think we are set. All right, so we got two options for machining this part. One is to run the mill at full speed, which means I need to have coolant blasting on the part. Otherwise, I'm gonna be getting built up aluminum edges on pretty much all the cutting tools due to the high speed machining we're gonna do. Or I can machine the whole part with coolant and then we can run it again, the same part as a dry cycle, just to kind of go through the paces again with the coolant off. And then we can talk about the different orientations. So I think what we're gonna do is machine the first part with coolant on at higher velocity, and you'll just see kind of a cloud of coolant in there. And then we'll run it again, and I'll probably just edit or speed up the coolant version first. So let's get at it. So we'll do memory and make sure our program is correct, and then hit cycle start. I'm gonna check that we're at 25% rapid, 100% speed, and 100% spindle. So I'll hit cycle start, and then let's check out the operation in the mill. And I'll have my finger on the feed hold. Since I'm here, it's a good practice to just be ready to stop for anything. All right, so I think I need to increase the pressure on the coolant. I was attempting to help save some of the machining footage, but these spigots aren't quite shooting where they need to be. This programmable nozzle is adjusting its position correctly, which is good. So what I did to pause the program so I could open the door is I basically did a feed hold, and then I told the mill to turn the spindle off, or not turn, yeah, to stop the rotation of the spindle. And then I also turned the coolant off. And now I'm opening the door to adjust our coolant. I may set the zoom or the focus to manual too. Yeah, this program is basically set for the limits of the tool and the material, assuming that we have coolant running at full blast. So that's why we've got basically a flood going on in there. All right, so I'm gonna turn the spindle back on by hitting the forward button on the controller, and it's telling me, "Are you sure?" And I'm gonna say yes by hitting enter. And then I'm gonna hit cycle start, and I'll turn the coolant back on first. So now we got a much more of a blast, and now I'm gonna hit cycle start, and it will continue where the program had paused. So we're here at the controller. Gonna hit memory, reset. Our program is at the top, and I'm gonna hit the cycle start with our feed rate, our rapid at 25%. So I hit cycle start, and I got my hand on the feed hold. Since we already ran this program once, should be pretty safe on running it again, since we're just dry cycling. I'll turn the coolant off so we don't have to hear the pump. Yeah, so this is the cut that we just ran, and currently we are at 100% feed rate, 100% spindle, and then here's the specs for our cut. 9,800 RPM and 50 inches per minute. Again, I'm basically rerunning this in dry mode just so you can see what's happening without the coolant spraying everywhere. But with these kind of speeds, as I mentioned, the tool would clog up with aluminum buildup on the cutting flutes pretty quickly. And this is actually an interesting test on spring, or is our parts relaxing when we start to tap it off at the bottom. And it sounds like the part maybe rolled towards the back in this stock, because I'm hearing some cuts on the back here, like right there. Some people call this a spring cut, where you cut away the spring action of the stock and the tool. It's used more in lathes than CNC, but some old timers will just run a CNC twice, or a CNC program twice, just to clean up the edges a little better. It's also a nice check to see that the 5-axis work holding system 6 million is actually holding the part correctly. See what that little... So yeah, it looks like it may have pushed over slightly, because we heard a little bit of ring there. Or that's cantilevered too. Maybe that could have been the issue. Yeah, because we got a diving board out there, so I think we just heard a ring on that diving board. Here we're cutting out the clearance from the top orientation. It'd be fun to check out the tool blend from this operation to the corner, the square corner clean out, and this part rotates. So we'll take a look to see how the radius clean out right there in that corner, and then this corner coming up actually blended out. And that kind of is a testimony to the MRZP, and I always get that acronym wrong, but the ball mapping of the trunnion that we did in the previous episode to calculate the math for rotating the trunnion and still holding the correct work coordinate system. So it could be that the stock did roll back a little bit in the vise, in our 6-inch bench vise. Some of these may get noisy with that diving board again. We're not actually that close to the tool setter. Very slight ledge on this backside. I am seeing some of that spring again. This is a test piece. It's not going to be a production piece. it looks like the stress relief from tabbing off is showing up in a couple of thousandths additional cut on the back here. I'm gonna have to keep shutting the coolant off, I think. The coolant pump is kind of noisy in this mill. I think Pearson Work Holding had a similar observation on YouTube. You can hear my vise handle flopping around a little. Now the light turned off. I'm going to hit coolant. And that should turn the light back on. Again, this is a demonstration part because we are probably rolled on that tab off tab. We'll see how the tapping goes. So this is a roll tap or a forming tap. So it doesn't actually cut, it just squishes the thread in. It'd be interesting to see if the zero or the start of that thread is the same every time, or is it random? I guess we'll find out. Yeah, it's definitely flexed a little on our hinge. Here comes the M5 tap, I believe. Oh yeah, I cut a new thread. It means it probably doesn't clock the threads or control the start of the turn or the thread start position, because it's re-tapping, it seems like. That's interesting. Now we're cleaning up some corners. This may ring All right, now we're going to deburr the edge. All right, so I need to turn the coolant back on since we're going to part off this piece in our dry run. So I'm going to tell it to stop the spindle and turn off the coolant. And we're already at cycle stop, or yeah, feed hold I mean. So now I can open up the door and we're going to turn our coolant back on. Like so. Program is still running, it's just paused with the spindle off, mostly just so I can open the door because there's a door lock key up there that won't let you get up in there. So now I will hit spindle forward and it's going to say, oh, are you sure? Warning, warning. So I'll say yes. Spindle's back on, turn on the coolant. Now we're spraying coolant and I will hit cycle start and our program continues to execute. So we're going to cut a tab in our part, but not cut all the way through. And this is going to be the end of the one operation or one setup fully machined part minus deburring the break-off tab that we're making right now. Oh, the rapid's at 25% since I was getting in there and doing stuff, so we'll see the table move 1/4 the speed when it's finally finished cutting this tab off. But this is the Dragonfly work holding system 6 million in operation for only 50 bucks. So now we're getting into the cut where we paused before. I think that is it. All right, there is our part. Now I can open the door. The tab is a little robust on this thing, but we can check out our part first. And then there you can see just a little sliver of metal there. Let me bust this thing off. It is possible to do with your hand. A rubber mallet may be a good idea so you don't wind up slicing your hand, but these edges are deburred. Here we go. So that little broken off tab, I'll just hit with the grinder and we are done. This is a full 5-axis part, one setup. So I'm over at the granite inspection and I'm measuring the dimensions of these parts. Now in this step I'm checking the run out of the surfaces. You can see there's about a 2/1000 difference in thickness from one end of this part to the other. I checked it a few times here. So yeah, just about 2/1000. Each tick is 0.5. So we'll check the other side and we'll probably get the same 2/1000. Yeah, so here's it's effectively the 2/1000. So now what we're going to do is, which is okay for these particular parts, now I'm going to check the step over from the Z-axis to the X-axis. This is when the trunnion rotated 90 degrees. And it looks like there's a 0.5 tool blend there. And again, you know, a lot of that surface was machined with the one orientation and then a vertical tool blend from the other orientation. So that's what I'm depicting here. I'm voiceovering, by the way, because the microphone kind of crapped out. And here we only have about half a thousandths run out on the surface flatness and parallelism to the bottom, which is pretty good. All right, well, I think that'll wrap it up for this week. Thanks again for watching Dragonfly Engineering. And I do plan on probably upgrading the Dragonfly 6-inch work holding system 6 million to something a little more appropriate. I hope to actually design my own work holding or 5-axis work holding system, which will have like a pyramid base with a fixed jaw and a moving jaw, but probably a toggle clamp, pneumatically actuated clamp, so that the KUKA robot here can load parts and pull parts and give the signal to clamp or unclamp. Or the alternative would be to buy some other 5-axis solution that's available in the machining community or on the internet. I'm not sure which, or I may do both, depends. So anyway, so thank you for watching, and if you'd like to click the like button and subscribe to the channel, that would help with the YouTube algorithm. And additionally, if you find this content educational or beneficial for your machining career or just your general knowledge, then maybe consider checking out my Patreon page as well and becoming a patron to assist me with buying things like the 6-inch vise, which I think was $35 or so.